So in this video, we're going to talk about the ANDing process and actually how that subnet mask splits the IP address. So you have the IP address along with the subnet mask, and how that subnet mask determines which part is the network and which part is the host part or the node part of that IP address when it's compared with that subnet mask. So let's just make this easy. So we can't always rely on the first 3 bytes of an address to tell us its class like we can when we're doing classful addressing like I discussed in the previous lesson. How exactly does a network node determine which part of the address is the network and which is the node? Well, it does it through a process called binary ANDing. So just as with decimal adding decimal numbers together, like for instance 3 plus 4 equals 7. When you add 3 and 4 together, you end up with 7. That's combining decimal numbers. Binary ANDing actually combines binary numbers in a similar fashion, but ANDing is a simpler process. Since there are only 2 values for a single bit, a 1 or a 0, we don't call it adding, we call it ANDing. It's more of a logical process than a summation process, and it works kind of like this. If you add a 1 plus a 1, that's going to equal 1. If you add a 1 plus a 0, that's going to equal 0. And if you add a 0 plus a 1, that's going to equal 0, and a 0 plus a 0 equals 0. Now I'm going to show you just a much easier process for looking at these if you ever have to AND 2 binary sets of numbers together like this. And I'll show you that just a little bit later on. But as you can see, when ANDing, really anything other than a 1 plus a 1 is going to equal 0. So the only time you're going to get a 1 when you're ANDing together is when you have 2 binary 1s added together, 1 plus 1. The rest of the time it's going to equal 0. So let's look at this in action. First, let's look at our previous example from our human perspective. We had, in the previous lesson, we had 128.32.15.22. That was our IP address that we were using as an example. And with that, since that was a class B IP address, we were using a subnet mask of 255.255.0.0. Now, let's look at the same address and subnet mask from the computer's perspective. Remember all those ones and zeros listed out there? Let's apply binary ANDing, and we'll kind of get an idea of how that subnet mask determines which portion is network and which portion of the IP above it is host. Notice that we AND the numbers vertically, just like an addition problem. Remember the rule, anything other than a 1 and a 1 is going to equal 0 when they are ANDed together. All the 1s in the subnet mask, in this case the first and second octets, represent the network portion. All of the zeros in the subnet mask represent the host portion. So that's based on that subnet mask, whatever subnet mask you're using. As far as the 1s go, that's where the breakaway point is for the IP address to split that IP address until that portion of the IP before that, where all the 1s were in the subnet mask, is the network portion that determines which network or subnetwork that host is in. And all of the zeros in the subnet mask are going to be telling it that those numbers that line up in that portion of the IP address above it are malleable, and they determine the host number that's on there. All of the zeros represent the host portion. This is an important point to remember when looking at subnet masks. When the subnet mask is applied, network bits are represented by 1s and host bits are represented by zeros. This is why we could only have those 9 numbers in any of the octets for the subnet mask. In the far right octet, any octet that has a number in it in the subnet mask would have to be one of those 9 numbers that we listed in the last lesson. And that's because they have to have consecutive 1s on the left-hand side, consecutive zeros on the right-hand side, and that determines the kind of division point where we're determining anything before that with the 1s is network, anything after that with the zeros is the host. So after ANDing, when we convert it back to decimal, we are left with the network 128.32.0.0. That's the network IP address. This means that of the original 128.32.15.22 address, the network portion is 128.32, determined by the 1s in the subnet mask. and the rest is the host portion. Okay, so I just want to give you an example of one of the little shortcuts that you can use. Now, if we're, again, in the human world, we use decimal numbers. We understand decimal numbers. 3 plus 4 equals 7. 9 plus 6 equals 15. Okay, but the computer world, they don't understand those kind of numbers. They don't understand decimal numbers. All they understand are ones and zeros. So, there are only certain combinations. You can only add a 1 and a 0, 0 and 1, a 1 and a 1. The only time you get a 1 in the binary world when you're ANDing two binary numbers together is when you have a 1 plus a 1, and that's going to give you a 1. Anytime other than that, if you have 1 plus 0, that's going to equal 0. 0 plus a 1 is going to equal 0, and a 0 plus a 0 is going to equal 0. So the only time you get a 1 is when you're adding two ones together. Just keep that in mind. The rest of the time you get zeros. It doesn't matter what the combination is. Okay? The little shortcut that I wanted to pass on to you is this, and I'm just going to draw an IP address here and a subnet mask. Let's see, let's just draw a random IP address up here. And then we're going to draw an 8-bit subnet mask up here. When you're adding these together, understand that in the subnet mask, now up to this point we're just dealing with classful subnet masks, so we've got octets that have 255 or 0. We'll get into variable length subnet masks in the next lesson. However, the little shortcut that I wanted to show you is with a subnet mask where there are always going to be consecutive ones followed by a breakpoint, then consecutive zeros. It doesn't matter what the subnet mask is. So when we get into variable length subnet masks, we're going to be dealing with within an octet. You can only use those 9 numbers that we talked about in the previous lesson in that octet because of the fact that those 9 numbers allow all ones consecutively up to a breakpoint and then all zeros, leading out to all zeros the rest of the subnet mask. Again, the subnet mask is just used to divide that IP into the portion that's determining what network or subnetwork they're in, what portion is the hosts or the nodes. The little shortcut that I wanted to show you is just simply this. When you have ones in the subnet mask, think of those as little bridges that are just carrying the value down from the IP address. So in this case, they would carry down 1011 1101. When you AND those together, that's what you get. Wherever there are ones, just think of those as little bridges that are just bringing that value down from the IP address, and where there are zeros, doesn't matter what's in the IP address, those are going to end up being zeros. This will give you the network, I have to spell correctly, address when you throw an IP address in there with a certain subnet mask. That subnet mask determines this is the subnetwork it's in, that's what it starts with. So, with that said, let's go back to the slides and I'll show you a little bit more on subnetting or subnet masks. Isn't there an easier way than ANDing? Sure there is. Remember, we're starting from the basics, so here it is. Subnet masks are like duct tape. What is duct tape used for? To stick things down so they don't move. How does this apply to subnetting? Well, remember the odometer example I gave you in the first video in this series? The zeros in the subnet mask represent the part of the odometer that is allowed to turn, or the part of the odometer that does turn. The 255s represent the parts that do not turn. And really more appropriately, the ones all the way up to the breakpoint in the subnet mask, determining where the breakpoint in the IP address is between the network portion and the host portion. All of those ones are really what lock down that portion of the IP address as the network portion. So, for example, if we're given the address of 200.100.50.15 and a subnet mask of 255.255.255.0. We can tell that the only part, now again, that's a classful subnet mask or classful address. We can tell with that the only part of the address that changes is the 0 part, the last octet in this case. Using this subnet mask, it's the last octet. If any other part, for example, the first 3 octets in this case, if any other part of that changes, we are no longer in the same network, or rather in the same sub-network. So as soon as that part of the odometer changes, or any of those portions in the 255 octets were to change on the IP address, we're in a completely different subnetwork. Okay? So let's try to clarify this a little bit more. If we were to binary add or AND together the IP and the subnet mask, we would see that the network portion is 200.100.50 and the host portion is 15. Let's duct tape down these first 3 octets because of the subnet mask so that they don't move, okay? Because we're going to stay within this network. Now, let's figure out which host IPs are in the 200.100.50.15 network given a 255.255.255.0 mask. So we can start, again, knowing that the last octet deals with the hosts because that's the 0 portion of the subnet mask provided with that IP address. We would start with 200.100.50.0, then up to 200.100.50.1, 200.100.50.2, etc., etc., all the way up to 200.100.50.99.100.101, all the way up to .254 and then .255. And again, since 255 is the maximum of that range in that last octet on the right hand side, as soon as that changed, it would cause again the next digit over to increment up. So it would move up to, if 255 were to be changed over to 000 again, or just 0, that would cause that next number over to rotate up to 51. Well, if that number changes in that octet with that subnet mask, we're now dealing with a different subnetwork. We're dealing with the 200.100.51 subnetwork. Okay? Let's see if I can explain this in a couple of other easy ways. Since the first 24 bits, those first 3 octets of the subnet mask are all ones, 255.255.255, which means we've got 8 ones in the first octet, 8 ones in the second, and 8 ones in the third. The first 24 bits, the first 3 octets of the IP address associated with this subnet mask are not to be touched. In other words, they are duct taped down because of those ones in the subnet mask. Since the question was what hosts are in this network, we only care about the last 8 bits or the last octet. The answer is that the 200.100.50.15 IP address with the subnet mask 255.255.255.0 is part of the network that contains the addresses from 200.100.50.0 through 200.100.50.255. That's the network that we're dealing with the IP address of 200.100.50.15 with the subnet mask 255.255.255.0. Let's try another. How about, and just to clarify this just a little bit before we move on, really what we're doing, just keep in mind what we're doing, if you go back to the concepts video that I talked about, what we're doing is we're determining what the range is of this subnetwork and what the host numbers are within that subnetwork. Let's try another. How about 130.100.0.0 with a subnet mask of 255.255.0.0? Well, we know that we're going to go all the way up from, we're going to start with 130.100.0.0, increment up 1.2.3.4 all the way up to .254.255. That, again, just like the odometer concept, is going to cause the next digit over to increment up 1. But since that's not duct taped down with the subnet mask, that second octet also is in the same subnetwork because of that subnet mask. So it will increment up 1, dot 1.0, 1.1, 1.2, all the way up to 1.255, and then dot 2, dot 0, etc., etc. You start to get the idea. We're still in the same subnetwork, though, based on that subnet mask, because that subnet mask determines that the first two octets define the network. The last two octets are all the host numbers that can be used inside that subnetwork. Notice that the same rules apply, but this time we duct tape down only those first two octets. The answer is that that network with a mask of 255.255.0.0 contains the addresses 130.100.0.0 all the way through 130.100.255.255. Notice how that odometer concept works. That's really all you need to kind of pick up here and start seeing. You can see how we rolled over from 130.100.0.255 to 130.100.1.0, then from 130.100.1.255 to 130.100.2.0, and so on and so on. So long as the first two octets do not change, we are still in that same network, or another way to say it is we're in that same subnetwork given these IP addresses and this subnet mask.